The next thing that we need to learn about in this class is how we organize data. So there are lots of different possible ways to organize data, but over the last several decades of people working with data and using computers to analyze those data, we have found that there is a single best way to organize it. And the way you do that is you treat each row in your data set as an observation. So you're using a table. And that would be the individual or subject or unit or item that you're measuring. So it's the source of information. That's an individual. And then each column is what we call a variable. And a key thing here is that when we say variable in statistics, we don't mean variable like we do in computer science or in algebra. In computer science and algebra, a variable stands for a single unknown value. But in statistics, a variable stands for a whole collection of values that are all measuring the same thing, but on different individuals or objects. And then those individual values that are measured occur in each cell of the table. And so those might be called measurements or values. So that's how we organize our data, and that makes it easy for the computer to understand what's going on. That everything on a row belongs to a single unit or person or item in your data set. Now to review, once you have put your data into your table, there are three kinds of variable that we mostly deal with in this class. First one, nominal, is a kind of variable that's discrete and has no order to it. So like names, zip codes, social security numbers, anything, colors, things that either there's no you could put them in order, but there's no intrinsic order to them. And so we call those discrete. We call them unordered. And SPSS calls them nominal variables. And I will sometimes call them categorical or grouping variables. So the role of a nominal variable in an analysis is to identify group membership. So if you belong to some group that has a name, the nominal variable names the group that you belong to. That's typically how it's used. It can also be used for individual identification, like if you put my name on a line of items, that would locate who you're talking about. So it can also be individual ID as opposed to a group. Ordered variables are also discrete, but they are, as their name says, ordered. So that means there's something about them that puts them in an intrinsic rank. So grades, ranks, sizes of like coffees, like tall, grande, venti, those are ordered variables because there's something intrinsic to them that puts, one goes between others. So SPSS calls those ordinal because that's the noun form of ordered, and I will sometimes call them ranked variables. We don't use them that much in this class because they sort of occupy this gray area between nominal and continuous variables. So if there's a small number of ranks, we'll often treat them as a group ID like we do nominal variables, and then not use them any farther, not really deal with the ordering that much, except making sure that when we graph them, they appear from smallest to largest or from least to greatest. And when there's lots and lots of levels, then we'll probably treat them as continuous variables, which is our last type of variable. So they are not discrete. We've considered continuous variables as having a whole unbroken range between their boundaries, so that they can take on any possible value. And when you have a lot of discrete things like dollars earned in salaries, you can divide it up into like dozens or hundreds of chunks, then that's effectively continuous, even if you can get to a point where you don't break things up any smaller. And so those continuous variables are always ordered. They cannot be unordered because you need that continuum for a range. There needs to be a range from smaller to larger for the continuum to work. SPSS calls those values those measure variables. And I will often call them real valued because they are real numbers if you take them out. And the role for those is to measure an amount. So they're never categorized in group, they're always quantifying some amount. So when we're doing measurements, sometimes statisticians talk about measurement error, and it's important to understand that that error is not something that results from a mistake, but it's error that results from unknowns, things that we haven't measured. And usually we choose not to measure them so that we have a finite amount of work to do in order to collect our data. Can't measure everything for everybody. And so when a statistician talks about error, they're talking about unexplained variation, not about mistakes. We hope and we proceed with our analysis as if there weren't systematic mistakes made. And so that whether there's systematic mistakes made in the measurement is beyond the statistics field. That has to do with whatever field that you're coming from and making sure that you're good at that job and doing a job measuring. Finally, sometimes when we're doing statistics, it can be a little confusing about what we're actually drawing our conclusions from, about what population we're actually examining. And so the individual units of the population that we're examining are called the units of observation. Sometimes those aren't actually the things that we directly measure. So for example, if we want to compare households, and we want to compare them in terms of like age or income or national origin or something like that, the units of observation are the households, but the actual things that we're measuring are the people in those households. And so we might measure, we might have a data frame where we're measuring people and recording what their people are, but then we'll need to summarize that to one where each row corresponds to a household. And we'll talk about that more as this class goes on in some of our data wrangling labs.